This is the last section we're going to do from Chapter 9, Section 9.4 for Algebra 2, Geometric Sequences and Series. So in previous lessons, we've learned about all different kinds of sequences and series, and in 9.3 we focused in on arithmetic, which are sequences that add the same amount every time. And now we're going to take a look at geometric sequences, which, by the way, you are multiplying or dividing by the same amount every time. So let's look at what a geometric sequence looks like. Here's an example. Serena Williams was the winner out of 128 players who began the 2003 Wimbledon Ladies Singles Tennis, by the way, championship. After each match, the winner continues to the next round and the loser is eliminated. So this is a single elimination tournament. If you've ever been in one for sports, you know what I'm talking about. So we started out with 128 for the first round, and then half of them won and half of them last. So half of them continued on. There were 64 in the next round and 32 and 16 and so on. So since each time we are multiplying by half or dividing by 2, we can call that a ratio of 1/2. So our common ratio is 1/2. So the big deal here is that you're going to need an R value. Just like for arithmetic, you need a D for common difference. Now you need the common ratio. If you are multiplying, this number will be bigger than 1. And if you're dividing, you need to turn it into a fraction. So don't say divide by 2. Say my common ratio is 1/2. So if you were to graph this, if we had a 128 and then 64 and 32 and 16 and so forth, you can see here that this would be an exponential curve. So the equations for geometric sequences are going to be exponential instead of linear. So first of all, we're going to kind of go back a little bit and we're going to look at some sequences and decide if they are geometric or arithmetic. So in order to do that, we need to compare these numbers, and you can compare them by adding and subtracting or by multiplying and dividing. So to check for arithmetic, you just subtract. What is 93 minus 100? 86 minus 93. And 79 minus 86. Make sure you go all the way because sometimes they might throw in some other letters. So if I'm subtracting the same amount every time, what kind is this? It's an arithmetic sequence, and the common difference would be the -7 that we are subtracting every time. So this section here, the answer can be geometric, arithmetic, or neither. So let's check this one. This one is going down 90, down 30, down 45 or something like that. So let's try division instead. So for division, I would do 90 divided by 180. Oh, I guess that's not one. Oh yeah, it went down by 90. That's what I said. That's a 1/2. And then 60 divided by 90 is 2/3. And 15 divided by 60 is 1/4. And if I do adding, that's actually minus. So those aren't even the same, and those aren't the same. So this one is neither. It's not arithmetic or geometric. There might be a pattern in there. I'm not sure what it would be. It can still be a sequence. Anything can be a sequence. And it could be a sequence with a pattern, but it might not be. So this one, it does not look like I'm subtracting, so I'm going to try dividing. 1 divided by 5 is 1/5. 0.2 divided by 1 is also 1/5. 2/10 is 1/5. And 0.04 divided by 0.2 is also 0.2, which is 1/5. So you can divide them in decimal or fraction. It doesn't really matter. So my R is 1/5, and this is geometric. Okay, so for these problems, make sure you name which type it is and give the R, the D, or neither. You don't have to put anything for neither. All right, so how do you find the next term of a geometric? Well, you take whatever the previous term was and you multiply it by whatever your R is. So this is a recursive formula that uses whatever I already had and multiply it to get the next term. So if I wanted the 10th term, this would not be easy because I would have to know the first and second and third and fourth and fifth and sixth, all the way up to the 10th term to get there. So we prefer, or at least I prefer, an explicit formula or general rule that will always get me there. We did this a little bit before, but this is an explicit rule because it doesn't rely on the previous term. It relies on the first term times the common ratio to the power of n minus 1. Notice there is no an over here. There's an a1 because that's the first term, but there's no an. So I don't need to find the previous term. I just need to take n minus 1. So let's see if we can write an equation for this. And that formula is on your formula sheet. The first one under geometric sequence formulas. So if I want to find the 7th term, that's a sub 7. Oh, that's my answer. Common ratio is divide like the second term divided by the first term, the third term divided by the second term, and so forth. And just make sure that every time you get the same answer, this is divided by 4, right? No, times 4. They're getting bigger. Times 4, times 4, times 4. 3 times 4 is 12. Okay, so my common ratio is 4. Keep that down. Now write a rule for the 7th term. So my formula is an a1 times r to the n minus 1 power. So I'm going to take my first term, which was 3 up here, times r, which I found, to the n minus 1 power. Well, if I was writing the rule, it would be an equals 3 times 4 to the n minus 1. Since I'm looking for the 7th term, I'm going to do 3 times 4 to the 6th power. Now, when you do this, 3 times 4 to the 6th power, it is not 12 to the 6th power, right? It's 4 to the 6th power and then times 3. So if you're going to type that in, make sure you type it in all at once and put the parentheses in the right spot, or you don't even need the parentheses, but the calculator will do it, right? Just don't do 12 to the 6th. That's not right. The answer, however, is 12,288. So keep in mind, because I'm multiplying by 4, these are getting huge really fast because it's multiplication. So getting bigger answers for this sum is acceptable. Here's another one. Also, just be careful. Notice these negative signs are alternating there, so look out for those. But let's see if we can find the 9th term of this sequence. So the common ratio, what am I multiplying by? The top didn't change, so we're going to make a 1 over, and the bottom is 2, but it alternated to negative. So 3/4 times negative a half. If I multiply this by a negative, it will become positive, and the bottom times 2. Yep, so the ratio is negative 1/2. The rule would be the first term times the ratio to the n minus 1 power. If I want the 9th term, I just stick a 9 in there, negative 1/2 to the 9 minus 1, or 8th power. I would not put 9 minus 1 in my calculator because then I have to type parentheses and a whole bunch more stuff. So I just think it's more efficient to do 9 minus 1 in your head and do to the 8th power when you go to type it in. Now, when you type this one in, you get a crazy decimal, 0.0029296875, blah, blah, blah. Okay, so I don't even know if it stops there because it goes all the way off my screen. Handy dandy tool, hit math, enter, and it will turn it into a fraction for you, which is just a lot cleaner. So I would prefer the fraction. Since these were in fraction, the answer should probably be a fraction. So that's my 9th term. Kind of lost my trail of notation there. That's what it would be. All right, this is one of those ones where we don't have the first term and we're missing a term. So if I know, let me just do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. These are my terms, and I know the 3rd one, and I know the 5th one, and I know it's geometric. So I know I have to be multiplying by something. Then this is how I would do it. Well, I know it's a multiplier, so I'm going to do divide 325 divided by 36. Right? 325 divided by 36. No, sorry. We're going to divide by r, but we don't know what. Hold on. I got to undo that real quick. Whoops, not divide. Oh, it won't undo. There we go. There we go. Okay, so 300, let's just do it like 325 is the 5th term, and we're starting with term 36. We would need to multiply by r squared, right? That is right. 324. It helps if you write the problem down right. 324 divided by 36. Okay, that's better. Okay, so my fifth term is 324. My third term is 36. Now I can divide by 36, which is what I was going to do in the beginning. And I know that that's two steps, which is times r, which is r squared, not 2r, but r squared. Okay. And since that's squared, I can square root it. So 3 is my r. One thing to keep in mind, though, is that it could be negative. I actually don't know because I have the third and the fifth term. The fourth term, it could be alternating, positive, negative, positive, negative. I don't know. So it's actually plus or minus 3 is what r could be. And that means my eighth term, I don't know either. So because it's an even one, it could be positive or negative. So let's finish this off and see if we can figure out what we've got going on here. So I think I'm going to fill in this little chart just to kind of help. So 36 times 3 is 108. So this one's 108, and I don't know if it's plus or minus. And 36 divided by 3 the other direction, this one's plus or minus 12, and divided by 3 is 4. The odd ones I know have to be positive because these were positive. All right, so I can go 6, 7, 8. I can do this 3 more times, or I can use the AN rule, which is the first term times my common ratio, which I just decided is 3, and we'll put plus or minus on it in a minute, to the n minus 1, and I'm going to the 8th. So a sub 8 would be 4 times 3 to the 7th, which is a huge number, 8,748. And remember, it could be plus or minus. I'm not sure. Ask me for an odd one, it would definitely be positive. So here's just a little warning notation here thing. Be careful. It could be positive or negative. One other comment about that is that this is not always squared. It depends on how many r's you have. So if I had like 5 steps away, this would be r to the 5th, and then I would have to take the 5th root of this number. So just keep in mind that this exponent's not always a 2. It just happened to be on this problem because these were 2 steps apart. Okay, let's go to the next part here. This is another example, but this one is only 1 step apart, so that's not super helpful. If I know the 4th term and the 5th term, I can just divide those to figure out what the r value is. So it's just 5. If I do negative 8 times 5, I get 40. So r is 5. And then I can find my 7th term. So if you want to pause the video and try it yourself, go ahead. Otherwise, I am just going to, I guess I'll go ahead and answer it for you. The 7th term, well, we got to find the 1st term. So to find the 1st term, this is the 4th. The 1st term would be, let's see, negative 8 divided by 5 to the 3rd power, right? Because I'm going to divide by 5, 5, and 5 to get there. So negative 8 divided by 5 to the 3rd is a decimal, and I'm going to write it as a fraction, negative 8 over 125, because that's 5 to the 3rd. And then the rule for A7 would be the 1st term times the common ratio to the 6th power. So I'm going to take what I had there from my last problem and do times 5 to the 6th power, which is negative 1,000. There's my 7th term. Okay, this is a little side note here from this lesson, and then we'll come back to sequences in a second. But geometric mean, so I'm not sure if you remember when you learned mean, median, mode way back, middle school maybe. The mean is actually the average. Okay, the reason that it's not called average is because it's also called arithmetic mean. Okay, the mean that you learned how to do where you add up all the numbers and then divide by how many there are is called the arithmetic mean. There is another kind of mean. It's a different kind of average, so we don't use the word average. And basically, you're going to up this a notch. So instead of this being addition, it's multiplication. And instead of it dividing by, it's the square root of. So the geometric mean is like a proportional amount of how much they are in the middle middle-ish. It's not really the middle either. It's kind of proportionally. Anyway, so basically all you need to know is this little formula. I promise this is super easy. All you do is multiply the numbers and square root it. The hardest part is that when they say geometric mean is to remember this formula to use. So make sure you've got that somewhere. But all you have to do is square root of the numbers times each other. So as long as you can type this in your calculator, you are set. The square root of 4/9 times 25/36. Math enter will be your friend here to turn it back into a fraction. That's it. Just in case you want, there's one more here. This one's even whole numbers. So multiply 16 and 25 and take the square root of that. Okay, what is the square root of 16? And what is the square root of 25? And what do you get when you multiply them? You get 20. So that's 4 times 5, which is 20. It's kind of like averaging. Anyway, okay, that was our little side note about geometric mean. Now we're going to go back to geometric sequences and series. So now we're going to add up all of the sums of a sequence that is geometric. And there is a formula for this on your sheet. Actually, there's 2 or 3. This little part here just kind of shows how you came up with it, but the formula is down here on the bottom. It's also on your sheet of formulas, and it's also right here. You do not have to memorize it. There's a little too much going on there, but all you need to know to find the sum of all those terms is the first term, the common ratio, and how many terms you're looking for the sum of. So let's try that out. We have a geometric sequence here because this is multiplying by 2 every time. So we found our R, and then we want to find S8. So on your worksheet, the formula for S8 is A1 times 1 minus R to the n over 1 minus R. Only thing you have to be careful of is when you put this in the calculator, you need parentheses around your top and parentheses around your bottom. You actually don't need the big blue parentheses there. So when I put this in my calculator, I'm going to take the first term times, I'll just show you what I would type in. Top of my equation is 1 minus 2 to the 8th divided by 1 minus 2. That is what I would type in. In this case, you don't need the 1, but times. All right, so 1 minus 2 to the 8th divided by 1 minus 2. You can subtract that in your head if you like. I got 255. So if I add up all these terms for the first 8 terms, it would add up to 255. There is a second formula on your sheet, and that one, basically you have to have the first and the last and the common ratio, so I hardly ever use that one. All right, here's one that is given to us in sigma notation. So if it looks like this, it is asking for the sum, and it says it here too, just to give you a hint. But this thing right here, this, if you ever see the symbol, it wants the sum. So don't just list out the terms, you got to add them up. First of all, plug in a 1 for the first term, 1/2. To the 1 minus 1, anything to the 0 power is 1. So my first term is 1. If I plug in a 2, just so you know, a sub 2 would be 1/2 to the first power would be 1/2. And I could keep going, and I would do the 6 terms, but that's enough. If I want the sum of the first 6 terms, I take the first term times 1 minus R. What is R? Did we figure out what R is? Well, what am I multiplying by over and over and over again? It's going to be whatever the base of the exponent is. So this number 1/2 is going to be what, every time I put another number in here, I'm multiplying by another half. 1/2, 1/2, 1/2, 1/2 is my R. So minus, and I would do parentheses 1/2 to the 6th power divided by 1 minus 1/2 in parentheses. If you don't do parentheses, your calculator won't do it correctly. So in mine, parentheses, 1 minus 1/2 to the 6th power divided by 1 minus 1/2, which is 1/2. I got a decimal, so I'm going to hit math, enter. 63 over 32, or 1.96875. Don't round because this is exact. All right, and that concludes our lesson. So you've got sequences and series. There's all different kinds, Fibonacci and others, special ones, but the ones we're focusing on are arithmetic and geometric. Make sure you know how to use your calculator if you want to. It is not required for this section. And make sure you have that page of formulas printed out. That would be very helpful. Good job, and thanks for finishing Chapter 9.